Hello all, hope you're doing well. So in the previous lecture we discussed about chemical bonds, we discussed about ionic bonds specifically. So in this lecture we are going to discuss about covalent bonds. So covalent bonds are basically on a basic level. Let's not go into more twists and turns, just the basic level which I'm going to discuss in this lecture. So it's a chemical bond. It's an attractive force formed between two or more non-metals. So that is one identity of a covalent bond. So if we say oxygen molecule like O2 is there, so if we say water is there, if we talk about carbon dioxide, so these all are basically non-metals. So non-metals means there will be covalent bond involved. So that's identity. So chemical bond formed between two or more non-metals in which there is mutual sharing of electrons from their outermost shell in order to attain nearest noble gas configuration. So now we are talking about sharing. See, when we have metal and non-metal, so metal behavior is to donate electrons, non-metal behavior is to accept electrons. But what if we have two non-metals? What we're going to do, what these non-metals or these elements are going to do in order to form a chemical bond over there? So they are going to share from their outermost shells. Now how this sharing takes place, that we are going to study. So if we say that two non-metals, in spite of their behavior to accept electrons, they do have a, you can say, a different way out to form a bond with each other. Like hydrogen molecule is there, oxygen is there, hydrogen, oxygen, both are non-metals, that is there. So again, they are sharing electrons from their outermost shell in order to attain nearest noble gas configuration. So how do they do that? Now in this, the way I explain, I actually intermix a concept, something called as valence bond theory that we teach in 11th grade, but yes, a simpler version of that, so that you can understand why, or you can say how these atoms can form a bond, like what is sharing at the first place. So we are going to take a very simple example, that is hydrogen molecule formation, H2, because this is why I've taken this example, because hydrogen has only one electron in it. Atomic number 1, it has only one electron. So now if we say, let's imagine we have a nucleus like hydrogen atom. So we have our minus this electron. So this is hydrogen A atom. Let's imagine that this is hydrogen B atom and there is electron. So we know that hydrogen, a normal hydrogen, has only one proton and one electron. So one proton we are showing over here in the nucleus, one electron over here. Similarly for hydrogen B atom. So now what is going to happen between these two atoms? So when they are going to come close to each other, so when they are coming close to each other, there will be some kind of interactions. Now interactions will be, this negative charge will be attracted towards this positively charged nucleus, if you can see this, and this hydrogen B atom electron, since it is negatively charged, will be attracted towards the neighboring nucleus. So I told you multiple times that chemistry is all about negative and positive attracting each other. So when these two atoms are coming close to each other. It's just like magnets. You know about north and south pole, right? So when you bring them close to each other, so you feel that attractive force at a certain distance. So when these two atoms come close to each other at a certain distance, there will be some kind of attractive forces. There will be repulsive forces also. So when the attractive forces are, you can say, balancing the repulsive forces, that is the time when bond formation happens. So these two atoms will overlap, the shells will overlap. So over here, so we'll just write about it. So what kind of attractive forces I'm talking about, and what kind of repulsive forces I'm talking about. So let's call this nucleus as Na, nucleus B, and this is electron B, and this is electron A, so that we can understand attractive and repulsive forces. So attractive forces will be between Na and Eb, will be between Nb and Ea, so opposite you can say charges. Then repulsive forces will be between say like charges, so between both the electrons Ea and Eb, and between nucleus B and nucleus A. So over here what we can understand is like so Na and Ea, okay, and two more attractive forces we can actually write between their own electrons, like Na and Ea also has an attractive force, Nb and Eb also has you can say attractive forces. So when these attractive forces, you can say, balance the repulsive forces, that is the time, that is the distance when bond formation happens. So how they are going to overlap? They are going to overlap like this. So electron over here, one electron I'm going to show over here. So just for understanding, so this is Na, this is Nb, and this one is electron B, this is electron A. Now if you can see one thing over here, this electron B is still inside the shell of its own atom. It's not leaving it, it's still there. But the shells, something we even call it as orbitals or subshells, that we'll be studying in the future classes, not over here. But yes, this electron is still existing in this shell, it's not leaving it. The shell is coming close to each other, they are getting overlapped over here, so the electrons are not leaving. But you can see this electron still sitting inside its own atom. It's actually, it's going inside the electron cloud of the neighboring hydrogen atom. If you can see Na, you can say hydrogen A, this is hydrogen A. And similarly, this electron A, which belongs to hydrogen A atom, is going inside the electron cloud of hydrogen B atom. So this is what we call overlapping of atomic, you can say, shells, or you can say, to be more precise, subshells, orbitals, we can say that. So in reality it's orbitals only, but over here, just for basic understanding, we can say that shells are getting overlapped. So this is how we show it. So now how to show with hydrogen molecule? We know hydrogen has one electron, so now the overlap you have to show. Now can you see in this entire circle we are putting two electrons, so that completes the valency of hydrogen. We know hydrogen has K shell, one electron, so after sharing one electron, K shell will have two electrons. So that we need to remember. Similarly, the left hand side hydrogen will be sharing this one electron. So you have to show this electron inside this loop, because this loop is indicating the atom, the electron cloud. So they both are similar to this. But we are not going to show this entire thing. This is only for understanding like how sharing is happening, what is the driving force. So the driving force are the nucleuses which are attracting the neighboring electrons. That is the driving force between a covalent bond. So co, like I always call it, it's not written anywhere, but I believe co stands for it's not written anywhere, but cooperation, they are cooperating with each other in order to form a bond. So this is how we show hydrogen molecule bond formation. So we just have to represent with a single line. So this is what we call as single covalent bond, and we even call it as bond pair of electron. So it's a pair of electron which participate in bond formation. So this was hydrogen molecule. Now we can take another example, that is oxygen molecule, O2, oxygen gas. So we know what atomic number of oxygen is 8, 2 and 6 configuration. So now we have to represent 6 valence electron. So we have to make sure that 2 electrons are in front of another oxygen atom. So you have to show 2 electrons over here for the bond formation. Rest anywhere you can show, like the other 4 electrons. So 6 valence electron, so you have to take these 2 electrons in this loop, you can say. So if you can see over here, 6 valence electrons are already sitting and they are sharing 2 electrons from this oxygen. So the octet of this oxygen after sharing 2 electrons is completed. Similarly, the left hand side oxygen is going to do the same thing here. Now if you count it, 1 2 3 4 5 6 electrons already sitting for this oxygen, it's going to share 2 electrons from the neighboring atom, and this is how a double covalent bond is going to be formed. So the rest of the electrons are going to just stay like that. So now whenever we say that bond pair of electrons, so I wrote single covalent bond, that means only one electron pair is shared between them. So we even call it as bond pair of electron. So this is what we call as a double covalent bond. Double covalent bond means you have to see 2 lines between any 2 bonded atoms. So, or we can even say it has 2 bond pairs. Bond pair definition I have already told, pair of electrons which participate in bond formation. So why two bond pairs? Because you have 2 lines over here, if you can see. But this entire entity is something called as double covalent bond. I'll define single, double and triple also. And then we'll come to this part. Can you see these 2 electrons? These 4 electrons sitting over here, right? For this molecule, they are not doing anything. But yes, they can participate in chemical reactions. We call these all 4 electrons, 4 pair of electrons as lone pair of electrons. All these are also lone pair of electrons. So if you count it, how many total lone pair, I'll define it, total lone pair of electrons are there. So total lone pair of electrons that we have are 4. And on each oxygen atom, if we see over here, on each oxygen atom we have 2 lone pairs each. Total in the oxygen molecule, it's going to be 4. So what are lone pairs? So lone pair of electrons are pair of electrons which generally participate in do not participate in bond formation. See, lone pairs, understanding lone pairs is, you can say, fascinating for me, because in most of the organic reactions, lone pairs play an important role for any kind of chemical reactions to start at the first place. So having a lone pair is something, you can say, it's something which, you can say, any lone pair sitting anywhere on atom can initiate a reaction, because they are electrons at the end of the day. They are negatively charged, so they will be attracted towards any positive center, so that can happen. So most of the organic reactions are facilitated because of the presence of lone pair or the absence of lone pair. So at least for this oxygen molecule, we even call these molecules as homoatomic molecules, that also I'll define. So these lone pairs are not doing anything, they are just sitting over here. So pair of electrons which generally do not participate in bond formation. So remember, I've told before in my classes, if you have listened to all my classes, generally term whenever I use, that means there are multiple twists and turns in the future, specifically in chemistry. So now we can define these molecules, then we'll define single, double and triple bond. So homoatomic molecules. So these are nothing but molecules of the same element. So example that we can put chlorine, hydrogen, oxygen, nitrogen, there are many. You can have a number of examples. Heteroatomic molecules. See, remember we are talking about molecules, we are not talking about compounds. Usually the term compound and molecule go hand in hand in most of the books. Compound is specifically a term when you have a metal and non-metal together. A molecule is a term specifically when you have covalent bonding involved. So these kind of molecules, or heteroatomic molecules, which are going to be molecules of different elements. So the example that we have is HCl, we have water, we have sulfur dioxide, n number of examples are there. You can keep writing. Now we come to classification. So classification of covalent bonds on the basis of number of electrons shared between bonded atoms. So this one I'm talking only for homoatomic molecules. I'm not discussing heteroatomic molecules, at least in this lecture. So again, if you hear any kind of disturbance in my background, please bear with me. So we have, on the basis of this, we have single covalent bond, double covalent bond, and then we have triple covalent bond. So single covalent bond we have already discussed, but double also we have discussed, but triple we haven't. So single covalent bond, only one electron pair is shared. So example, you can write hydrogen, you can write chlorine, you can write fluorine molecule, halogens, 17 group elements, fluorine, chlorine, bromine, iodine, etc. So over here I'll just show for one halogen molecule, so that you can practice for the rest also. And do remember, all halogens are nothing but 17 group elements, have 7 valence electron. So in this chlorine, fluorine, bromine and iodine, even if you don't know atomic number of bromine, iodine, fluorine and chlorine definitely you do know, but if you don't know bromine and iodine, so you just have to show 7 valence electrons. I'll take an example of iodine. So 7 valence electron you have to show. So 7 over here, then another iodine atom. Even if you don't know atomic number, that's okay, but at least we know that valence electrons are 7. So again, you will complete its octet. So since it's 7 valence electrons, it's going to share 1 electron. So it's going to complete its octet. Similarly over here. And we are going to have iodine as a single covalent bond. And if you count, how many lone pairs do we have? We have total 6 pairs of lone pairs, right? So 3 on each iodine atom. So you can try for bromine, you can try for chlorine, fluorine, all these 4 elements you can try on your own. Hydrogen we have already done. So double covalent bond, 2 electron pairs are shared. So this is the electron pair. If you can see, this line represents electron pair. If you can see over here, this is 1 electron pair. So 2 electron pairs are shared. So we are talking about oxygen molecule. So we'll keep this example only. We have already discussed about oxygen. Triple covalent bond, 3 electron pairs are shared. So the example over here that we're going to take is nitrogen molecule. So let's come to nitrogen. So nitrogen atomic number is 7, 2 and 5 configuration. Now how many electrons it requires in order to complete its octet? So it requires 3, right? It needs to share 3. That's the valency of nitrogen if you go back to the basics of chemistry, where I've discussed atomic number, electronic configuration and all that. So now over here you have to show these 5 valence electrons in this manner. The 2 electrons, you can see, you have to show these 3 electrons in front of another nitrogen atom, because we need to show the bonding on pen and paper, right? So the 2 electrons over here you can show anywhere. You can show on this side, you can show on this side. Like, at least there is no hard and fast rule that it has to be at the top, or you can say over here. So it's okay, at least for 10 grade it's fine. So now we have to show the overlap. So you have to take these 3 electrons. So now you can understand why I've taken these 3 electrons, because nitrogen is going to share 3 electrons in order to complete its octet. So 3, 4, 5, 6, 7, 8. Octet of this nitrogen is done. Similarly, the left hand side nitrogen is going to do the same behavior here. So now we will show 3 lines, because there are 3 electron pairs involved over here. And how many lone pairs we have? We have LP stand for lone pair, 2 lone pairs. And we have how many bond pairs? For bond pairs you count the lines. There are 3 lines. And you have 1 triple covalent bond. This entire entity is called as triple covalent bond. So this was nitrogen molecule. On each nitrogen, 1 lone pair is there. On entire nitrogen molecule, how many lone pairs? 2. So this is how we can remember it. So now this is partly about the covalent bond. But yes, we have another story about covalent bond, where you have different atoms like HCl, water. We discussed heteroatomic molecules. Now what story is there, how they are bonding, and does it are they showing, you can say, something different compared to the homoatomic molecules? So yes, there is some difference. That classification we'll be discussing in the next class. Meantime, please like, subscribe and share this video. If you find it useful, please share it to your friends, share it to your class friends and everybody, and try to circulate this so that it can be, people can benefit from these information and they can score well in their exams. So scoring well is not the only agenda, it's understanding a concept, and that will give you confidence ultimately, and you'll be able to do better wherever you are. So thank you very much for listening to my video, and see you again in the next video.